Hello class, this is Mr. Lehman. I want to talk to you today about Smells Unit Lesson 2, Molecules in Two Dimensions. And so we like to draw molecules in the form of 2D models. We can actually draw them in 3D, but it gets a little bit more complicated. For simplicity's sake, chemists usually draw things in 2D, at least at lower levels like our class, introductory courses. And so up to this point, we've been using strictly molecular formulas. For example, C2H6. So that tells us we have 2 carbons and 6 hydrogens in our molecule. The structural formula shows us not only what atoms are present, but they also show us the shape and which order they're bonded in. So it tells us, particularly how the atoms are arranged and how they're bonded together. And so C2H6 ethane would have this structure. This is a structural formula. This is a molecular formula. Structural formulas are much more helpful because, like I said, they give you an idea of what the shape is like and also the order of arrangements in the bond types that are present, single bonds, double bonds, or triple bonds. So let's take a look at these 2 molecules here. If you were to predict what these things smelled like, according to Lesson 1, they both have 2 oxygens, and so therefore you might predict that both of them are sweet. However, if we look at the names, this one ends in ATE. We know we like to eat sweet things, so we ate it. And so this would definitely be sweet. But this one ends in ic acid. Things that end in ic acid are carboxylic acids, which we'll learn about in the future. These things smell putrid. So how can that be? How can 2 things with the same molecular formula have different structures or have different smells? It's because they have different structures. So if I were to draw this, it might look something like this. And each place where I have a line, that's where I attach my hydrogens. That gets pretty time consuming. That's why in future lessons, once we get good at this, you can just leave the lines empty. You don't have to draw any H's because chemists assume that there's hydrogens attached to the carbon because that's usually what they combine with. Pentanoic acids are a little different. All 7 of those carbons are going to be linked up in one long straight chain, perhaps. And the oxygens are going to be, let me draw it the way that you can recognize it here. And so I'm not going to draw in all the hydrogens here. Just assume that any place I don't put a letter, there's a hydrogen there. And so we can see a key difference here. Here, the oxygens are in the center. Here, the oxygens are towards the end. That difference in structure gives these things different smells because our nose, the receptors in our nose, pick those up as 2 different shaped molecules. So this one, which is sweet, is recognized by one smell receptor in our nose, which signals our brain, yummy, good smell, eat me. This type of molecule combines with a second type of receptor, which our brain signifies as being putrid, nasty, do not eat me. Alright, finally, we have a new vocab word. These 2 things here, because they both have the same formula, C7H14O2, but they have different shapes, different structural formulas, these are what we call isomers. These are what we call isomers. That's the vocab word, biggest word in Lesson 2, isomers. Things that have the same formula but different shapes, different structures. So my question to you, are these isomers? Are these 2 things isomers of each other? They both have C3H8. They both have 3 carbons, 8 hydrogens. Are they different in structure? The answer is no, absolutely not. Because we can take this one, rotate it 90 degrees, and it's the same as this. So all the atoms are connected in the same way, so these are not isomers. Hopefully this helped you with Lesson 2. Have a great day.